Alrighty, hello everyone. So today we're going to be talking about acids and bases. They're everywhere. Ooh, okay, let's get it started. Alright, so what's an acid? Hope you're looking at this cute baby. So it says acids have hydrogen ions. So whenever you see something with an H plus, that's a hydrogen ion. You'll also hear me call it a proton. Let me try to write this out. Proton. Proton. Great. This is beautiful handwriting. I'm so sorry. Okay, so acids have hydrogen ions or protons. They're the same thing. And the more hydrogens, the more H pluses that the compound has, the more acidic it will be. All right, now our properties. How do we know if something's an acid? Well, the first thing is you can taste it. If it's sour, it's an acid, but we don't taste things in chemistry unless I tell you to. But I'm sure you can think of some examples of stuff that you've had that taste sour, like lemons, limes, things like that, citric acid. They conduct electricity. Shocking. And they are corrosive. Acids are corrosive, meaning they break stuff down, like your skin. They can break down paper, and they also like to react with metals. They react strongly with metals, and they turn litmus paper red. Magical. Acids turn litmus paper red. Okie dokie. You can see this beautiful picture down here. We got acids turning this blue paper indeed red. All right. All right. Uses of acids. So you can see them most commonly, which you'll be around, is food. So vinegar, lemons, limes, oranges, sour candy, Sour Patch Kids. Those are my favorite. Then you have ascorbic acid, which is vitamin C. You've probably heard of that, like we're talking about immune system and seeing things like the vitamin C powder that you can mix into water to keep you from getting sick. Sulfuric acid used in fertilizers, paints, plastics, and also car batteries. I know some of you might have worked on cars and you've looked at your battery because your car died and there's like this powdery green stuff. That's acid, battery acid. Bases, bases. Okay, so bases, you could call them the opposite of an acid. They have OH ions, hydroxide ions. And we might also see the word alkyl, which is another word for base or something that is basic. Bases accept hydrogen ions. They love them. They want to grab those hydrogen ions. And if you notice, which is friggin' fancy, OH has what charge? Negative. And what is the charge on a proton? Positive. They like each other. This makes water, H2O, when they bond together. Okay? Next. Properties of a base. They are slippery. They taste bitter. Your mom or dad, somebody has ever made you eat soap because you said a potty word. You will know what I'm talking about because soap is a base. They can conduct electricity. Think of an alkaline battery. I should have put a picture of that on here. It's fine. They don't react with metals, and they turn litmus paper blue, base blue. And then reacts with acids to form salt, not like table salt, but a salt, and water. That OH plus an H plus makes water, H2O, that I was talking about earlier. All right, so what do we use bases for? Why do we care? Well, bases are used in cleaning. They help cut grease, that slippery and abrasive qualities that bases have. Abrasive. Okay, sorry. So their qualities are good for cleaning. They're also found in chalk, and your blood can be basic. Typically, we'll see that blood is neutral, which we'll talk about in just a moment what that means. But usually, we'll say it's basic for these purposes. There is something called ketoacidosis, which is a problem with the blood where your blood becomes too acidic, aka the acid part in ketoacidosis. And it can cause heart attacks. It can actually kill you. No good. No bueno. All right, the pH scale. Wow, look at this beauty right here. So we have, let's see, our pH scale goes from 0, yes, to, oh my God, this is a really straight line, to 7. Wow, I just killed it drawing that line. So from 0 to 7, I chose red because red, acids turn litmus paper red. So 0 to 7 we say are acids. And then from 7 to 14, definitely not going to be able to do this one nearly as well. I'm going to try though. I'm trying very, very hard. Oh, shoot. It's fine. From 7 to 14 are the bases. 7 is neutral, so that's water for you. The way I remember, this is super, super silly, but the way I remember which way is acids and which way is bases, I'm going to draw this fantastic cloud. And has everyone heard of acid rain? If you haven't, there you go. There's a thing called acid rain. And I'm going to draw my raindrops as little lines. And what do these lines look like? Would you say they look like ones? I would. So for acids, I think of acid rain, and then when I think about me drawing a cloud that's raining, it looks like the number 1, so I know low numbers from 1 to 7 is an acid, and then 8 to 14 is a base. All right, so here's just a quick little flow chart about naming acids. We've already talked about this. Whenever there's only 2 elements, it's a binary compound. We have hydro, IC, like hydrochloric acid, that's just a hydrogen and a chlorine. And then if you have 3 elements, it gets a little bit more complicated. And if something ended in ATE, it then changes to IC. And then if something ended in ITE before, it becomes OUS. Like sulfite becomes sulfurous, and then sulfate becomes sulfuric. So we've talked about this before. There's just a quick little refresh. All right, and then our last little bit that we're going to talk about for acids and bases are Bronsted-Lowry acids and bases. So Bronsted-Lowry, they were scientists who studied acids and bases, and they said for something to be an acid, it must donate a proton. So what does donate mean? Donate means to give away, to lose, however you want to put it. They're going to donate a proton. So acids are giving away, they're donating an H+. Okay? Bronsted-Lowry bases accept a proton. Accept meaning to take on, to get. So Bronsted-Lowry bases accept a proton. And if we think about a base, we talked about just a moment ago, it's an OH, and the charge on that OH, the hydroxide, oh goodness, is, let's try that one more time, is negative, and this negative charge will be attracted to that positive. So it's ready to take on that H+, and whenever these two things bond together, that makes good old water, H2O. Alrighty, and that's all we're going to do today for the properties of acids and bases. Thanks, guys.